Hello, scholars, and welcome to Mr. Chambers Teaches HMH into Math for 5th grade. Today we are working on the Module 2 review. These are pages 51 and 52 in your Unit 1, Module 1 through 9 workbook. In this video, we will go through the Module 2 review, reviewing our strategies for division and vocabulary terms for things that may appear on the Module 2 test. Feel free to skip around in the video to find help working on the particular problems you may need help on. To start off with some vocabulary, we have some terms here: compatible numbers, dividend, divisor, partial quotients, quotient, and remainder. Number 1. When estimating a quotient, it is best to use blank that can be evenly divided. For this, we are using compatible numbers. Compatible numbers we use to help us estimate what our quotient will be. Number 2, the method of dividing by subtracting multiples of the divisor from the dividend uses partial quotients. And lastly, the number that results from dividing is the quotient. Anytime we are dividing, our answer is a quotient. All right, concepts and skills. Number 4, which of the following best describes the division equation represented by this area model? For this, we're going to count up all the squares going lengthwise and all the squares going widthwise to find out how many total squares there are and which of these problems best represents it. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. We have 19 up top times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. For this problem, we have 19 times 12. Well, 19 times 12 is here in number C for 228 divided by 19 equals 12. Number 5. Select all the division equations for which 50 is a reasonable estimate. Tell what strategy or tool you will use to solve the problem, explain your choice, and find the answer. So we're estimating for number 5 here. And to estimate, we're going to be using some comparable numbers or compatible numbers. For this one, let's see 1400 divided by 25. If I know my multiples of 25, I know it's 25, 50, 75, 100. Well, 100 is good. 100 could go into 14 times, and that's times 4. 4 times 4 is 16. All right, so we estimate about 56 for this. Is 50 a reasonable estimate? Maybe. Let's see if we can find others that are closer, but with our estimate being 56, we can try this again when we come back to it. All right, using our compatible numbers, 30 and 1200. 30 times 12 would be 40. That seems a little low. B's out of the question. 40 is a little too low for 50 to be a reasonable estimate. Now, 3,000 divided by 60 as our comparable numbers. Figure out how many times 6 can go into 300. That would be 50. C is a definite one where 50 is a reasonable answer for this problem. D, I have 4,000 and I have 80 as my compatible numbers. 80 can go, or 8 can go into 450 times, so D is acceptable. And lastly here, 382 divided by 71. I already know that 50 is way too big, that this can only go in about 5 times. So E is out, D is good, C is good, and we'll also accept A as being reasonable. So A, C, and D are all reasonable to have 50 as a good estimate. All right, we're going to do the odd number problems on page 52, 7, 9, 11, 13, and 15. For number 7, using compatible numbers to find two different estimates. Well, I can round this to 40, and I can round 648 to, let's say, 640 as our compatible numbers. How many times can 4 go into 64? Well, once minus 4, 2, carried out by 4. 4 can go in there 14 times. Okay, so first estimate, 14. Another way we could do this is, what if we round this up to 50 and 650? 50 could go into 600, be 12 times. Yeah, that would be 600. Leaves us with an additional 50, so 13 times. All right, so I can estimate that we are between 13 and 14, whether I'm using compatible numbers of 40 and 640 or 50 and 650. Okay? So just estimating what the best possible number could be. For number 9, a local company donates 1,935 ounces of granola to a local food bank. Volunteers are making 85 smaller bags. What is a reasonable estimate for how many ounces can go into each of the smaller bags? So, looking at our problem, I find that our divisor is 85, that's the number we do know, and our dividend is 1,935. Using comparable numbers, let's say this could go to 80, and this could go to 2,000. How many times can 2,000 go in? Or 80 go into 2,000, take off my extra zeros. 8 can go into 21, or 2 times, minus 16. Leaves us with 40. And 8 can go into 45 times. So we estimate 25 ounces in each bag. Okay. Other reasonable numbers that we could round to, 90 and 2,000. Again. Take off our zeros. 9 can go into 20 twice, minus 18, twice, 22. So between 22 and 25 ounces would be a reasonable estimate for how many ounces of granola can go into each bag. We don't need to actually solve it yet. We just need an estimate. All right. Number 11, 31 into 591. Well, if I think about my multiples of 31, I'll write them over here on the side. 31, 62, plus another 31. Let's make that 93. 9 plus 3, 124. 155. 186. 7 plus 8 plus 3. 11. 217. Plus another 248. 279. 310. Okay, so those are my multiples. See that times 10, 310. I can subtract from here, so that's 10 there. 591 minus 310 leaves me with 1 minus 0 is 1. 9 minus 1 is 8, and 5 minus 3 is 2. 281. Well, looking here, my ninth multiple here, 279. Fits in nicely, and that's times 9. And that will leave me with a remainder of 2. So this is 19 remainder of 2. Okay, so that's using my partial quotients. Anytime I can use a 10 makes life nice and pretty. But let's try this just here. How many times can 31 go into 59? Well, that's 1 time. It's 31. 8. 2. And carry down my 1. 281. We said that was 9 times. 278. And that leaves me here. Alright, so 19 is our answer, whether I'm doing long division or partial quotients. Next up, dividing 1,718 divided by 23. Okay, so I can write out my multiples of 23. 23, 46, 69, plus 3, that's 2, 72 plus that, 92, 5, 115, 138, 140, 161, 184, 7 plus 207 plus 23, 230. All right, write out my multiples. Let's see if I got anything that's close. 115, that would be times 1, 2, 3, 4, 5. But this would be 50 because I want to subtract 100. Like so. All right. Subtract 17, 18 minus 11, 50. 8 minus 0 is 8. Can't do that, so I regroup. 11 minus 5 is 6. 6 minus 1 is 5. All right, 568. Well, I see that I can do a group of 10. Minus 230. 8 minus 0 is 8. 6 minus 3 is 3. 5 minus 2 is 3. All right, I can do another group of 10 minus 230, and that will leave me with 108. The closest I could get to 108 is 92 here, so 1, 2, 3, 4. 8 minus 2 is 16. All right, now I add up all these partial quotients, 50, 60, 70, 74. With a remainder of 6. All right, let's double check this. Let's use some comparable numbers, see if this is reasonable for what we got. Round this to 25, and that to 1,700. 25 times 4 equals 100 times 17. 4 times 17. 4 times 7. 28. 4 times 1, 4 plus 2, 68. So we estimate 68. We have an actual of 74. I think this is reasonable for problem number 13. All right, our last problem for this is 84. And how many times 84 can go into 4,500? On my side, I can write out my multiples of 84. 84 plus 84 will give me 168. Plus another 84. 2 plus 1. 7 plus 8. 252. 252 plus 84. 336. Plus another 84, 420. Plus 84, 504 plus 84, 588 plus 84, 672 plus 84, 756 plus 84, 840. All right, first 10 multiples. What's close here? I like 42, but remember this would be with an additional 0, so it's 1, 2, 3, 4, 5 times 50 minus 4,200 leaves us with 300. Closest I could get there is 252. That's times 3, leaving me with 48 here. All right, so we have 53 with a remainder of 48. Okay. Double check our math real quick. Let's use some comparable numbers. Let's see how many times 80 can go to 4,500. Take off the last 0. 8 could go into 45. That looks like it's 5 times minus 40. It's a bit of a 55. So we estimate about 55. Our answer is 53. This is a reasonable answer. So 53 with a remainder of 48. This concludes our video on HMH into math for 5th grade. I'm Mr. Chambers, and I thank you for taking your time to watch this video to improve your math skills, and I look forward to speaking to you again in our next lesson, Module 3, Lesson 1.